Okay, now we're going to find equations of a parabola in standard form when we're given certain properties of that parabola. So in the first example, it's given us that the vertex is 0, 0. So if I draw the picture, here's my vertex at 0, 0. It says the directrix is at y is equal to 1. So that's my horizontal line, y is equal to 1. And it tells us also that the focus is at the point 0, negative 1. So that tells me that my value of P is 1, because the distance from the vertex to the focus and from the vertex to the directrix is 1 in either direction. This also tells me, even though we don't know how wide it opens, we also know that it's going to have to open down because of the positioning of the vertex with the focus and the directrix. And because it opens down, we know that the value of P is going to be negative, and we know that the standard form is going to be x minus h squared is equal to 4p times y minus k, because when it opens up or down, it's the x term that's going to be squared. So when I plug in my values for h and k, which is 0, 0 in this case, my vertex is at the origin. And when I plug in the fact that p is 1, and that p has to be negative, I'm going to get negative 4, and then y minus 0 is just y. This is going to be the standard form of the parabola given the properties in the example. In example 2, we're told that the vertex is at 1, 3. It tells us that the directrix is at x equals negative a half. So the line x equals negative a half is a vertical line when x is negative a half. And the focus is at 5 halves, which is 2.5. So that tells us that the distance from the vertex to the focus is 1.5, which can be written in fraction form as 3 halves. And the distance from the vertex to the directrix is also 3 halves. So we know that P is going to be 3 halves. We also know that because of the positioning of the directrix in the focus, it's going to have to open to the right, which means P is going to be positive. And it also means that because it's opening to the right, and my term with the y in it is going to be what's squared when I write this in standard form. So I'm going to have y minus k squared is equal to 4p times x minus h. So this is the form we're going to use. Since my vertex is at 1, 3, my h is 1 and my 3 is k. So I have y minus 3 squared is equal to, and then in parentheses I have x minus 1, because my p is 3 halves, or 1.5. When I take 4 times 3 halves, that's going to give me 12 halves, which is 6. So this is what's going to be in front of the parentheses x minus 1. And so this is going to be the equation in standard form of the parabola with the given properties. In example 3, we have the information that's given to us in graph form. So we're going to have to pick the information from the table in order to come up with our standard form of the equation. Now, the parabola is opening to the left, which means my value of P is going to be negative. It also tells me that I'm going to use the form of the standard equation where the y term is squared. I can see from the graph that my value of P is 1 because the distance from the vertex to the focus point is 1. But because it opens to the left, I know that p has to be negative, so I'm going to write it down as -1 for p. My vertex is going to be at -2, +1. That's my h and my k. So when I plug all this in, I'm going to get y minus 1 squared is equal to -4, because I have 4 times p, which is -1. And then x minus a -2 gives me an x plus 2. The standard form of the graph shown is y minus 1 squared is equal to -4 times x plus 2. In example 4, we're also given the graph, so we have to pick the information from the graph. Since the parabola opens up, I know my p is going to be positive, and I can also see that my p is going to be 2 because the distance from the vertex to the focus is 2. Because it opens up, I know that I'm going to use the form of the equation in which the x term is squared. So I'm going to have x minus h squared is equal to 4p times my y minus k. And I'm going to plug in all my information. My vertex is at 2, 0. So my h is 2 and my k is 0. So I'm going to plug in x minus 2 and square it is equal to 4 times +2 is 8. And then I have y minus 0. I could also write it without the 0. Either one is fine, but here is the standard form of the equation given the graph of the parabola. Okay, in example 5, last example of finding the equation given certain properties. It says the vertex and the endpoints of the lattice rectum of a parabola are given. Find the equation. So here's the picture. Our vertex is at 0, 0. The lattice rectum is at the points -4, 2 and +4, 2. So that tells me how wide the parabola opens. Because from here to here will be my lattice rectum, which means by symmetry, my focus has to be in the center of that. So this is going to have to be my focus. So I can look at this one of two ways. I can see that my P is the distance from the focus to the vertex, which is 2. Or I could also see that the distance from here to here I know is 2P. And since that distance is 4, P would have to be 2. So either way, I can see that my value of P has to be 2. And P is also going to be positive because the graph of the parabola is opening up. Because it's opening up, I know I'm going to use the standard form of the equation where the x term is squared. So I'm going to use x minus h squared is equal to 4p times y minus k. And now I just have to plug everything in. Since my vertex is at 0, 0, I'm going to have x squared is equal to 4p, which is 4 times 2 is 8, and then y. Now if I want to, I can write the 0 in there, but I don't have to. Either one is fine. And again, that is because my vertex is at 0, 0, so my h and k are both 0.